Hello and welcome to this special edition of Live and Ticking in partnership with MacMillan Cancer Support. I'm Fearghal McKinney, Head of BHF Northern Ireland, and today's event is on cancer and the heart. Cancer and heart disease are two of the leading causes of death worldwide. They share some common risk factors such as smoking, obesity, and high blood pressure. They also affect each other in complex ways, as some cancer treatments, unfortunately, can cause damage to the heart. Similarly, some heart conditions can limit the ability of cancer patients to tolerate certain treatments. Today, we're delighted to be joined by Dr. María Sol Andrés, a cardio-oncologist and research clinical fellow at the Royal Brompton Hospital, whose primary role is to care for cancer patients that develop cardiovascular disease during and after cancer treatment. But she also sets time aside to work as a clinical advisor and specialist reviewer for MacMillan. Sol will be giving a talk on how cancer and heart disease interlink and what support is out there for patients with both conditions. Then we'll hear from Philippa Coffey, who has experience of just that. Philippa was diagnosed with lymphoma in 2015. After 8 courses of aggressive chemotherapy and going into remission, she began feeling breathless and was eventually diagnosed with heart failure. More from Philippa shortly. Our final speaker today will be BHF-funded researcher Laura Booth, who is currently completing her PhD at the University of Newcastle. Her research project is focused on understanding why some anti-cancer drugs cause heart cells to not function correctly, with the aim of finding ways to target these cells to prevent or even reverse anti-cancer drug-related heart disease. If you have any questions for our speakers today, you can submit them via the Q&A box throughout the talks. We'll also be joined by lead clinical nurse specialist in cardio-oncology and heart failure at the Royal Brompton Hospital, Fearghal, for questions later. We'll try to answer as many questions as possible during the Q&A. However, if we're unable to answer your question, then you can call our heart helpline and speak directly to one of our cardiac nurses. Alternatively, you can also call the MacMillan support line. We'll drop the details of both in the chat box now. You can also join our Health Unlocked community forum for support. This forum provides a safe space to discuss living with any heart or circulatory diseases. All of our incredible research is funded 100% by you, the public. If you're inspired by what you hear today, then all donations to support our life-saving work are very much welcomed and appreciated. There's a link to donate in the chat box, should you wish to do so. Finally, before we hear from our speakers, I'd like to ask you a quick poll question on how would you rate your understanding of cancer and the heart? 1, of course, being very little, and 5 being a lot. Just let you cast your votes now. Okay, now it's my pleasure to introduce our first speaker today, María Sol Andrés. Over to you, Sol.
Good afternoon, and thank you so much for the kind introduction. And thank you all so very much for being here with us and joining us in this webinar. It's a pleasure for me to speak to all of you about cardio-oncology and what we do in a cardiac clinic that looks after cancer patients. So let me see if this works. So before we dive into understanding what cardio-oncology is, let me tell you a little bit about myself, or actually a short story here. When I was a young medical student back in the year 2000s, cardiology books were already very thick. They had at least 1 or 2 volumes, but interestingly enough, the section dedicated to cancer-related heart disease was only at least, at the most, I would say, 2 paragraphs. Let's fast forward 20 years from then, and we have now dedicated cardio-oncology textbooks. We have manuals, we have cardiology textbooks that dedicate chapters and subsections in cardio-oncology. We even have patient targeted or dedicated literature. These are leaflets from MacMillan Cancer Support that you can download from the website. And this is a very recently published cardio-oncology guideline that is for patients. Now, why has this happened? Why has there been such a dramatic increase in available resources about cardiology and cancer? And let me show you a few more numbers. It's not just the resources that have increased tremendously. It's also the number of patients referred to a cardio-oncology service. These are numbers from our service, the Cardio-Oncology Center of Excellence at the Royal Brompton Hospital, where we can see that the number of referrals and the number of total consultations have increased exponentially in the last 10 years. Well, why has this happened? I like to call this a story of success, and allow me the biased picture here. But 20 years ago, cancer treatments were quite limited. The truth is, it's quite sad, but patients who were diagnosed with metastatic disease or certain types of blood cancers, of lung cancer, they probably didn't survive very long. So what happened to the heart in a couple of years after the cancer treatment was not the main interest. The main focus of the treatment was to reduce or shrink the tumor size, improve the quality of life, which is very important. But obviously, there was not much interest in the long-term side effects of these treatments. Now, this has changed. And why has it changed? It has changed thanks to the revolution in cancer therapy. So this is why I call cardio-oncology a story of success, because thanks to success in the new therapies, so targeted therapies, immunotherapies, cellular therapies for cancer treatment, it has allowed patients to survive longer and longer, so long enough to be able to get cardiovascular disease in the long run, is that we now cannot overlook anymore the previously ignored cardiovascular side effects. So as a result of this story of success, cancer medicine and cardiovascular medicine are now two medical worlds that have collided. And cardio-oncology is not getting any simpler. As we speak, there are new therapies available. It's hard enough for us, the cardiologists, to learn how to pronounce these new therapies, and they get another one in the market. And this is great news for patients. But there is a downside to this. And I would call it a downside or a trade-off, actually. It has to do with this. The fact is that cancer is a consequence of exaggerated cell division, increased cell numbers. Tumors are lots and lots and lots of cells all together, and they are fed by new vessels. So more blood flow into the tumor is needed, and increased metabolic activity. On the other hand, heart disease is a consequence of all the opposite, of failure in cell division, of low blood flow, of impaired or decreased energetic efficiency. So when we are treating cancer and trying to stop the progression or the growth of the tumor, we will inevitably have or affect the heart and the cardiovascular system. So this is why cardio-oncology exists nowadays. And what is cardio-oncology? Well, cardio-oncology is the subspecialty in heart medicine that is interested in preventing, early diagnosing, so detecting it early, and if needed, treating cardiac disease or cardiovascular disease that is as a consequence of cancer treatment. And it's not our own job, but it's our main job. And if we put it in simpler words, we can say that our job is to do everything that's in our power to allow you, the cancer patients, to receive the best cancer treatment available without the trade-off, or with the lowest trade-off possible. What we don't want is to switch one disease for another. And what kind of toxicities are we talking about? Well, our next speaker will talk about heart failure. Heart failure is the weakening of the heart muscle, and this is the best understood cardiac toxicity, but it's not the only one. High blood pressure, blood clots in the arteries or the veins, chest pain, arrhythmias, inflammation. The spectrum is quite broad, and depending on what treatment you are receiving, what toxicity we will be expecting. So what can we do? As the medical team, we will monitor for any signs of heart problems. When? Before, during, and after your cancer treatment. But you, as the patient, we need you to report any heart symptoms to your medical team. Remember to take any heart drugs prescribed. So how do we monitor your heart? There are very simple tests, such as an electrocardiogram and blood tests. There are a little bit more complex tests, but harmless and painless, such as ultrasound of the heart, and some more complex, even more complex tests that are done only in specialized centers, such as cardiac magnetic resonance and cardiac computed tomography, that allow us to understand in depth what's going on with your heart. With all this information, so your medical history, the results of the tests, the type of cancer therapy that you will be receiving, we can calculate, and we can calculate broadly, but we can also use specific calculators to calculate your risk of developing cardiac toxicity during your cancer treatment. And if you are considered low risk, then you will start cancer therapy without any further delays. Now, if on the contrary, you are categorized as high risk, then a referral to cardio-oncology might be very beneficial for yourself. What are the risk factors? So what are the factors that might contribute to increasing the toxicity? Because obviously not everybody has cardiac toxicity when receiving cancer treatment. Well, if you have a cardiac condition prior to being diagnosed with cancer, this will increase your possibility of having cardiac problems during your treatment. Then if cardiac condition runs in the family, also, if you have some of what we call the classic or the traditional cardiovascular risk factors, such as high blood pressure, high cholesterol, diabetes, smoking, unhealthy diet habits, those all also contribute to the increased risk of toxicity. The results of the tests, and then if you've had a previous cardiotoxic cancer therapy. All of this sounds very bad, but there are things that you can do as a patient to reduce your own risk. So making healthy lifestyle choices, it sounds obvious, but watching your diet, trying to keep up with exercise, weight control, and smoking cessation is very important. This will reduce the risk of having to stop your treatment or interrupt it unnecessarily. Working with your medical team to manage your cardiovascular risk factors. If you had been previously diagnosed with high blood pressure, diabetes, or high cholesterol, don't ignore this during your cancer treatment. They are as important. Taking your prescribed medications and discussing any new symptoms that you might have. Which are these new symptoms? So if you have palpitations, you'll feel your heart racing, you have chest pain, you notice your legs to be swollen, you are more fatigued or short of breath or dizzy than before. Don't worry, they might not directly mean that you are having a cardiac problem, but just let us know. That's your main job, to let us know, and we will do our job. So with this I close. This is my final slide. We know that this might be very challenging times. If you're undergoing cancer treatment and you are told or diagnosed with a cardiac complication of your cancer treatment, it might be very challenging, but you should not be doing this alone. There are support lines from MacMillan, BHF, and the Cardio-Oncology Centre of Excellence is based at the Royal Brompton Hospital in London. So at the end of the day, the truth is that in order to ensure that you have a successful journey through your cancer treatment, We all need to work together. So thank you very much, and back to you.
And thank you, Sol. Our next speaker is Philippa Coffey, who has lived experience of both cancer and heart failure. Philippa will be joined by Jana Theodorou from the BHF Research Engagement Team. Welcome, Philippa and Jana.
Thanks, Fearghal. Hi, Philippa.
Hello. Hi.
Thanks so much for being here today. We really appreciate you sharing your story with us. To start us off, why don't you tell us a little bit about yourself, where you're from, your job, your family?
Okay, I'm from Rotherham. I'm actually an advanced ultrasound practitioner, so I work at the hospital. I was diagnosed with non-Hodgkin's lymphoma in 2015, and I like to think I was lucky actually in being diagnosed with it because it was purely by chance. I don't know if anybody listening to this, apart from the medics, will be aware that blood cancers are very difficult to actually diagnose. And all the symptoms I was experiencing were attributed to other lifestyle factors. I was extremely fatigued, so that was put down because I was 51 at the time, but it was the menopause. I was also looking after two very ill parents. I'd got back problems, but working in an AHS environment, like a lot of people lifting and moving and handling patients, that was attributed to that. The night sweats again was put down to menopausal symptoms. So it's purely, which maybe I shouldn't do, I scanned myself. So did an ultrasound scan. It showed some peculiarities on one of my ovaries. And luckily, because I worked in radiology, was able to say, could I have the CA125 specifically for an ovarian cancer diagnosis if it was raised? And it wasn't. They actually decided, though, to put me through an MRI scanner, which took us all by surprise and showed lymphoma in my chest, spine, pelvis and right femur. And from there, it was just one thing after another, lots of different tests, a lesion removed from the chest, and the diagnosis ultimately of stage 4 non-Hodgkin's lymphoma that had also transformed into a very aggressive stage. So it was no hanging about. We needed to get on with chemotherapy straight away.
Yeah, and you had 8 courses of chemotherapy, didn't you? What was that like?
Good. To be fair, I think I was very naive, although I've got a background of working in the NHS and heard lots of patients I've come across, as well as other professionals, discuss chemo. Didn't realise how harsh it was. I didn't tolerate it very well at all. From the test injection on the first day, I reacted badly, so they decided to put a PICC line in to administer all the drugs from there on. Within 2 days of the first chemo, I was admitted to hospital with severe headaches, so much so that they thought the cancer had spread to my brain, so I had to have an MRI scan. And it wasn't, I just wasn't tolerating the toxicity of the chemicals. So instead of having chemo every 3 weeks, it was split. So I had chemo week 1, week 2, week 3 was off, if you can call it a break, and then starting the procedure again. And then it was just every side effect under the sun. I think everything that's been written about side effects, I ended up ticking every box. So yeah, it was harsh.
Yeah, no, it sounds it. And when did you start feeling that sense of breathlessness?
Breathlessness started actually not far into the chemotherapy, but unfortunately, because I've got a history of asthma, and I was told it was just normal for patients going through a chemotherapy, it was sort of sidelined until I was admitted in September with pyrexia, which they didn't know why. I'd got an infection. That was then pushed to one side. But a couple of weeks after that, I developed a DVT in my PICC line. So it's a subclavian axillary DVT. And it was on the back of that then we seemed to be channeled down the have I got a PE, which to anybody that doesn't know is a clot in my lung. So I had a CTPA to see if I'd got one of those. I hadn't. And again, it was just, no, it's normal for chemotherapy. Just referring to the previous speaker, it sounds as though things have progressed so much, even in this short period of time, the 9 years since my diagnosis, because everybody seems to now be talking about the connection between chemotherapy and heart problems. At my stage, it was never mentioned at all. It was all attributed to potentially lung, respiratory, or normal for aggressive chemo.
And when did it actually become clear that you had heart failure?
Not till actually the chemo had finished. I finished chemotherapy on the 22nd of December 2015, and I expected a few weeks to get over that. But then I was told I was in remission in January. I thought, right, we're on the up here, you know, I can start to feel better. And instead I was feeling worse. I was becoming more breathless. I couldn't walk upstairs. I was crawling upstairs. The fatigue was getting worse instead of better. During the chemo, I'd had chest pains, but because they were around my sternum, I was told it was the chemo just targeting the blood cells because the sternum is rich in red blood cells. So I was just blown over. I didn't know what was happening, but nobody was listening to me still. And it wasn't until I started the next round of my treatment that it all became evident as what was happening. I was due to have some monoclonal antibody treatment, which other cancer patients may be aware of. And it's more a preventative procedure for 2 years to try and delay the cancer coming back. And I was going for a blood test prior to that, and I collapsed in the hospital car park. Still, I was channeled to the respiratory department, even down to the sort of fact that they wanted me to have some physio to retrain my breathing because they said it was traumatic and I'd got just to relearn how to breathe properly. Came to nothing, so I had an echo, and it was the echocardiogram that showed my ejection fraction was 18%, which, well, it just sent everybody into a mad spin. Yeah, that was...
And what were you thinking hearing that? Because I know that you saw your dad go through heart failure, looked after your dad through that.
Yeah, to be honest, on the day that they told me, it sort of hit, but didn't hit and register, as it does with a lot of these diagnoses. And up till now, everything else I'd just treated as though I was in the third person, as it were. I was going through it, it was me, but I wasn't the patient with the cancer. But maybe because I could relate to Dad, it hit me that evening when I was at home on my own. And yeah, suddenly mortality and everything. You've survived one major illness, although that was never going to be cured. And I knew eventually it's just going to come back. And yeah, suddenly, what do we do with heart failure? Especially as Dad had only died only a matter of months before my diagnosis. He died in 2014. So yeah, it was extremely frightening.
Yeah, I mean, that's so much for any one person to go through. But I know that you still have this incredibly positive outlook, and I just want you to talk a little bit about that, because you have so much strength.
Oh, I don't think so. I think it's like most people, you know, you can either sit back and just, you know, take what's happening to you, lie down and just end whatever sort of nice things are in life. Mine isn't. Life's short. That is the one thing I've realised. You don't know what's around the next corner. I'm absolutely grateful to, I can't put in words, that I'm here. I was told that I wasn't supposed to survive more than 6 months with the lymphoma. Then I was told 5 years maximum. We're now 9 years, which is wonderful. The heart failure has improved through working with the specialist heart nurse, who was absolutely superb. She was the one that actually then put me in touch with MacMillan again, who supported me. So I've now got my ejection fraction up to 34%, which is tremendous. Yes, I still have the side effects. I have days when I can't breathe. My mobility is not brilliant. But yeah, just don't concentrate on the negative. And again, I know the previous speaker was saying, please monitor all your symptoms and report them. But equally, I don't know whether I'm supposed to say this or not, but do not become obsessed with them. I did. Probably because it's that medical background I come from.
Yeah.
But initially I was told to monitor blood pressure and heart rate. And it became, I was doing it every half an hour. And yeah, psychologically, it wasn't good for me. I know now just to listen to my body rather than anything else, and don't look at figures. I have never had high blood pressure. So the usual triggers don't fit my story anyway. So no, just listen to yourself, and yeah, don't put off what you want to do it.
Yeah, I think there's probably a balance there, isn't there, of keeping track but not becoming obsessed and burying yourself in a hole about it.
Yeah.
And has your outlook changed sort of on life since you've been through this? Like, do you feel like you have a different perspective?
Yeah, I just say I think life is for living. And I suppose as well, this is why I still work. I only work part-time. But because I'm interacting with other patients, it's a great leveler. There are always people far worse than I am, others that I know that started off with similar diagnosis as I had in 2015 are no longer here. So just be grateful for every moment. Yeah, just don't put anything on hold. Travel isn't easy, as a lot of people will probably be aware of who are listening to this, but it's still possible. Get over the stigma of having to use a wheelchair if you do need to. I'll ask for assistance through the airport, and it works fantastically. Just don't wear that label that you're sick, but just equally get on with living.
Brilliant. Thank you so much, Philippa. That is some great words of wisdom.
Okay.
Thank you so much. Fearghal, back to you.
Yes, and thank you too from all of us, Philippa. We really appreciate you sharing your story with us today. Our final speaker today is BHF-funded scientist Laura Booth, who's going to share with us a bit about her research into this field.
Okay. So as Fearghal mentioned, I'm a researcher. I'm the research speaker for today, and my research focuses on these cancer chemotherapies and how they can impact the heart later in life. So I like to sort of think about these cancer therapies as kind of, are they the hero or the villain of this scenario in a sense? So I'll just begin with a quick introduction to myself and my career so far. So I'm originally from Sheffield, so not far from Philippa and Rotherham there. And I did my undergraduate degree in York. So I was there for 4 years, and whilst I was there, met some really, really inspiring academic researchers who inspired me to carry on with research and pursue maybe doing a PhD. So I did that, and I came to Newcastle, where I'm based now, where I'm doing a 4-year PhD. So I'm nearly finished with that now. And this is with Gavin Richardson and Jason Gill as my supervisors, studying the cardiotoxicities of these chemotherapies that we've been speaking about today. And during the PhD, I've had a real privilege of going to various places to speak about my research. I love talking to people about science. I'm a self-confessed geek about it, and taking part in lots of sort of outreach and communications schemes as well about science. So Sol introduced this really nicely earlier, but as you'll probably be aware, so this project is based in cancer survivorship, and unfortunately, the risk of cancer for British people is now 1 in 2. However, on a much, much happier note, this is a success story. So 1 in 2 of those who are diagnosed will now survive that diagnosis for 10 years or more, which is brilliant news. So bringing these two things together, we know that we have this growing cancer survivor population on our hands, and we need to make sure that we're looking after these patients who have this very specific medical history. Now, there are many reasons that this cancer survival rate has improved so much over recent years. Again, as Sol introduced so nicely earlier, things like better awareness of how to spot cancer symptoms, better screening to catch cancer in an earlier stage, and some really effective treatments that are available to us. Now, the medicine that I'm particularly interested in is called doxorubicin, and this is a really fantastic chemotherapy drug. It's often given intravenously in a drip, and it was invented in the 60s and 70s, so it's been around a long time. But considering it's been around that long, it's still a first choice treatment for a lot of common cancers like leukemia, lymphoma, sarcoma, and breast cancer. So a really, really fantastic chemotherapy. Now, most of us in the room today will know somebody who has received chemotherapy or perhaps received chemotherapy ourselves. And you might be saying to yourself now, hang on a minute, Laura, you're saying that these medicines are fantastic and amazing, but that's really not how I remember my chemotherapy journey being. You might remember how exhausted and in pain a loved one was during treatment. I remember how my mum's hair fell out and how difficult that was for her. Or you might remember how everything that you ate just tasted like sawdust during your treatment. And unfortunately, you'd be totally right. Chemotherapies are potent drugs, and they do, unfortunately, have side effects. So I like to think of this as a little bit like a superhero film where, let's say you go to the cinema to see the latest, greatest Marvel film or whatever's been released recently, and you see Superman fighting off the latest baddie, and they do battle across New York City. And at the end of the film, the battle is won, the goodies have won, the baddies have lost, and the dust settles, and the camera pans around, and you see that skyscrapers have fallen, cars are on fire, the city is in ruins. And this is a little bit like your body during chemotherapy. Your body becomes a battleground and takes collateral damage during this very strong, harsh treatment. So as I mentioned, the drug that I'm interested in particularly is called doxorubicin, and this has been known to cause heart problems for cancer survivors later in life for quite a while. It's often referred to as being the red devil chemotherapy drug because it's bright red in colour, but also it has these really notorious side effects, unfortunately. So the timeline will often go a little bit like this. A patient will receive doxorubicin chemotherapy, and in the short term, an injury is done to the heart whilst they receive that chemotherapy. The patient's heart will gradually become worse, but the patient won't initially experience any symptoms. And months or even years later, the damage will grow and grow, unfortunately, until the patient will eventually experience heart failure symptoms. And it then becomes about managing that heart failure later on. So we can think about these patients as kind of being these ticking time bombs in a sense. But it's important to note that not everybody gets these cardiac side effects. In the case of doxorubicin, estimates vary, but it's thought that anything from 5 to 37% of patients might develop these heart problems later in life. And that figure depends on a lot of factors that Sol alluded to earlier, that I'm sure we'll be happy to chat through in the Q&A later as well. So how does doxorubicin actually work at the molecular level? Well, when a patient receives doxorubicin's job is to damage the DNA of cells, which kills them off. So when DNA is damaged, unfortunately, breaks occur in the DNA. Now, what's really important here is that doxorubicin is a really stupid drug. It's just a molecule, it's just a medicine, and it can't tell the difference between healthy cells, which we want to leave alone, and the cancer cells, which we do want to damage and kill off. So DNA for a cell is a little bit like our cells, so the building blocks that our bodies are made out of. DNA is a little bit like an instruction manual for a cell. It tells a cell what to do, where to go, even who to be. And when the DNA is damaged and gets breaks in it as a result of this doxorubicin treatment, for the cells, it's a little bit like half of the instruction manual just suddenly goes missing, and it doesn't know what to do anymore or where to go. And this sets an internal alarm system sounding in the cell. If this goes on for long enough and the cell survives with its internal alarm system sounding, it leads the cells to become what's called senescent. So we often refer to senescent cells as being like zombie cells because they stop dividing forever. They have a really disturbed, weird metabolism. They belch out these horrible, harmful substances into their surroundings, which can encourage inflammation and disease. And importantly, they resist dying. So they stick around and they cause problems for their environment, for the tissue around them, instead of just dying off. So tying all of those things together, what was our big idea with this research? Our idea was that doxorubicin chemotherapy causes heart failure because it makes heart muscle cells senescent via DNA damage. These senescent heart muscle cells cause problems for their environment, and this encourages heart disease over time. So to explore this, I work in a lab. So this looks like my general day-to-day in the white lab coat and the gloves. And I do experiments on human heart muscle cells in a dish. So we decided to treat these human heart muscle cells with doxorubicin chemotherapy, and then take the drug away and let the cells just recover and sit there for 10 days. At the end of the 10-day period, we then have a look at the cells and see how they're different. And we look at that by looking at them under the microscope and also examining their DNA and their genes. So the first thing we wanted to know is, can chemotherapy make human heart muscle cells senescent? So we had a little look at our cells under the microscope, and in particular, we looked at the nucleus, which is kind of like the brain of the cell, and it's this little round bit in the middle of a cell. And the things that we looked for on our checklist to try and answer this question are two proteins called P16 and P21. Doesn't particularly matter what they're called. What's important is that they tell a cell to stop dividing, and they're really important red flag markers of senescence. So those were our kind of checklists. So looking at our cells down the microscope, this is a bird's eye view, and all the nucleuses of all the cells are in blue here, those blue circles, and we've painted this protein that we're interested in, P16, in a green colour. So in our human heart muscle cells that haven't been given any chemotherapy, we can see that there's a little bit of green on the screen, but there's not really very much green laid on top of the blue circles. So there's not very much of this senescence marker in our cells. But when we look at the cells which were given doxorubicin chemotherapy, these nucleuses, they light up like Christmas trees, and they have this really bright spotty green pattern inside them, telling us that there is P16 in these cells. Similarly, when we looked for P21, which is this other senescence marker, this time painted in red, we saw that there was some of this marker in our cells not given chemotherapy. But when we look at the cells that were given chemotherapy, 10 days after their exposure, there was a lot more of this P21 senescence marker in those cells. So from those pictures, we could tell, okay, we have these two red flag senescence markers in cells given chemotherapy. So the other bit of experimental data that I want to tell you about is a little bit different. We know that our cells are looking senescent after chemotherapy with that small checklist. So next we decided to think big and open up our approach a little bit. So in cells, the DNA which lives in the nucleus is used to make instructions out of RNA. And this gets sent out to the rest of the cell and beyond, a little bit like an internal messaging system. So essentially, if a cell is responding to changes in its environment or to a stress, we should see this reflected in changes in the RNA. So it's really useful to examine this RNA in experiments. So we did this and we looked at all the RNA in the cell, there was a lot of, and to be honest, we're still unpicking this data. But 10 days after chemotherapy, we saw that heart muscle cells showed lots of changes in their RNA. Essentially, what we can see here is that every dot within this square is an individual gene. So there are 14,000 dots on this graph, if you believe it. Anything that is in blue is a gene that goes down after chemotherapy. Anything that's in red is a gene that goes up after chemotherapy. So we found out what these genes were, and some of them are a little bit familiar to us based on our previous research and based on other people's research. But some of these genes that change after chemotherapy are actually brand new targets to us, which is really exciting. So there are 500 or so genes that we're looking into that's come out of this research. The take-home message from this data is that lots of genes change in human heart muscle cells after they've been treated with chemotherapy, and we're still digging into this data now. So just to recap, and what do we do with the information I've just shown you? So we know that chemotherapies like doxorubicin can cause heart disease later in life, and we think a process called senescence is partly to blame, where heart muscle cells become zombie-like because of the DNA damage that occurs, and that encourages heart disease over time. So we're now starting to paint a picture of what these zombie heart cells are like. But why? The aim with all of this information is to know thine enemy, so that we have a better chance of targeting this disease. And we might be able to fight the zombie cells a little bit like Wonder Woman here. So looking forward to the future, we're hoping that one avenue might be, firstly, can we kill the zombies? That is, can we develop medicines to get rid of senescent cells that are causing so much trouble? And there's a really exciting group of medicines called senolytics, which are being developed to do just that. On the other hand, could we think about curing the zombies rather than killing them off? So that is, can we develop medicines that change or reverse the bad aspects of senescent zombie cells? And there's a class of medicines being developed called xenomorphics that do that. Lastly, in the clinic, outside of these risk factors that Sol mentioned earlier, it can be quite difficult to predict ahead of time who might get heart disease after chemotherapy, after we've accounted for all of those traditional risk factors. It would be really nice if we could use some of the ideas that we've mentioned today to develop, for example, in the future, a blood test that might predict who is a little bit more at risk outside of those traditional cardiac risk factors, so that we could keep a closer eye on them after their chemotherapy treatment. So in conclusion, doxorubicin, this chemotherapy that I'm interested in, hero or villain? Well, doxorubicin has saved millions of lives over the 50 years or so since it was invented, but nobody's perfect. By researching these flaws, like how chemotherapies can cause senescence, we hope we can prevent today's cancer survivors from becoming tomorrow's heart failure patients. And lastly, looking towards the future and how the BHF is supporting us, we're really excited to have been awarded a research project grant from the British Heart Foundation, which will fund a 3-year project supporting further research into this project on chemotherapy, cardiac side effects. So all the data that I told you about today is looking at the muscle cells of the heart. And though the heart is a muscle, it also has other cells that help to make up the organ. So we're interested in those too, and we'd really like to cast our net wider with our investigations. Secondly, the thing that I've really appreciated since interacting more with the BHF and this research is that it really facilitates a lot of collaboration with other BHF-funded units and researchers, whether that's at events like this or academic conferences and so on. So we've had some really great chats, for instance, with the South Tees Academic Cardiovascular Unit. And a lot of these collaborations now involve clinicians, which is really useful because those links allow us to keep our lab research relevant and useful for patients in the real world, which is the end goal above all. So I'd lastly just like to thank my supervisory team, and colleagues who have contributed to this research, and to yourselves for listening. Thank you very much.
Thank you very much, Laura, for a really clear presentation, and I love the imagery. Now we're going to welcome back all speakers for the Q&A portion of the event. To support answering your questions, we also have Priya Fearghal with us. Priya is a cardio-oncology and heart failure clinical nurse specialist, and we're delighted to have you here today, Priya. So if you have any questions for Priya, Philippa, Laura, or Sol, please leave them in the Q&A box now. And of course, throughout the talk, some of you have already been doing that. I asked the questions in the most upvoted form, so it comes to me. Priya, it looks like you're first. So if you had chemo in the past and have angina, are you likely to have issues along these lines later on?
Possibly, but we do, for our patients, we usually encourage conducting a baseline risk assessment. So that assesses the factors that we can't change, things like being female, male, and age and things like that, and then also brings in past medical history, i.e. any cardiovascular condition, sorry. So that would, knowing that somebody has had angina, we would then carry out appropriate tests, so an ECG, a blood test, which would include cardiac biomarkers, and that would then produce a kind of risk assessment to show if a patient is low risk, medium risk, or high risk. So if a patient has already had angina, that would, we put in all the other factors of their history, and accordingly there would be surveillance, so i.e. any blood tests or an ECG or echo that we would do along the way. So they may or may not have angina symptoms, but it's, yes, it's, I don't know, Sol, if you want to add anything to that.
Yeah, it probably depends on what type of chemotherapy they had the previous time when they had chest pain. So there are some specific agents such as 5-FU or capecitabine that can cause chest pain and can cause angina, vasospasm. So it doesn't affect the heart cell, the cardiac cell, as Laura was talking about, but it causes vasospasm. If the new therapy is based on those kind of treatments, then the likelihood of developing chest pain again is very high. Now, if they are going to receive other different type of therapies, and the patient doesn't have established coronary disease, which we can check with all the things that Priya mentioned, then it might not happen in the second time. So yeah, it's very personal. It's very tailored.
Okay, thank you, Maureen Simpson, for that question. Something similar here, and jump in where you feel you can. Are certain people more likely to develop heart problems from certain people more likely to develop heart problems from chemotherapy drugs, and is there a way to know who they are? You touched on this.
Well, yeah, I've showed you that there's the cardiovascular, the classical traditional risk factors that increase the risk of toxicity. And again, nowadays, we are not only focusing on the risk of developing toxicity with doxorubicin, which is a very, very big part of our jobs, but depending on what type of cancer treatment, the type of toxicity that you can get, and then the risk factors or the risk will vary depending on the so yes, not everybody is at the same baseline risk, and that's why we do this baseline assessment. And in 2020, Heart Failure Association with the International Cardio-Oncology Society released a very important document with different risk calculators for each different group of drugs, because we are not talking about one type of toxicity for one type of drug. We're talking about different type of toxicities for different type of drugs for different type of people. So yes, there are. And what can we do? Well, again, what we talked about during my presentation, what can the patient do about it is it's very similar to reducing the risk of any cardiovascular complications in your life, as having a healthy diet, doing exercise. If you're smoking, trying to search for help to reduce that or to stop it as possible. And then there are some medical options that we can also offer. Sorry, maybe Laura and Priya want to also.
Yeah, if I could jump in really quickly. Yeah, all really fantastic points. I think there's some exciting research, although it is just still confined to the lab, which is looking into how each person might absorb and metabolize and excrete their treatment a little bit differently. So although, you know, broadly our biology is the same, everybody is very, very different. So those sorts of things might affect who develops toxicity and who doesn't. Part of that might be due to our genetics. But I think we're not quite there yet with the research to establish a firm link, but I think that's a really exciting avenue that's developing at the moment. The other thing I would say that I've heard quite a few researchers interested in recently is thinking about how radiation therapy might also contribute. So we hear quite a lot about, for instance, breast cancer patients who might receive therapy for the left breast in radiation therapy, and then they might also in tandem receive a chemotherapy, which is known to have risks of cardiotoxicity. So bringing those two things together might increase risk as well. So I think thinking about cardio-oncology and holistic care, it can be really important to think about other treatments as well, which might be radiation based, I would guess. As not a clinician, but it's just something I'm hearing chatter about, I guess, in the research side at the moment.
Yeah.
The context of this is all more complicated, but one specific question is asking which cancer drugs are most commonly associated with cardiotoxic effects.
Laura, that's your area.
That's your bag, Laura.
Well, is the vedette here, is the main character here, is our bread and butter. Yeah,
for sure. Yeah, I mean, so doxorubicin, the drug that I study in particular, it's been around that long and it's still so commonly used that I think it is the bread and butter cardiotoxic example of a chemotherapy. But there are 3 other drugs in the same drug family that are also cardiotoxic, although the one I spoke about today is kind of probably the most work has been done on that. But that family of drug is called the anthracycline family of drugs. But there are others out there which are cardiotoxic, which I think, you know, I would say we know less about. Priya and Maria, you probably know more, but all of these new advents into cancer chemotherapies are so interesting. Things like immune checkpoint inhibitors, for instance, really exciting and have helped combat cancer so much. But I think, yeah, we're starting to ask questions about, we need to be mindful of long-term survival. I think the thinking is changing, as perhaps Philippa mentioned.
Philippa mentioned another type of drug which is very well known associated with cancer complications, which is the monoclonal antibodies for so in breast cancer. There's a type of breast cancer which is HER2 positive, and nowadays we have antibodies that can target that specific molecule, and the association between anthracyclines and anti-HER2 therapies increase the risk of toxicity, of cardiovascular toxicity a little bit more as well. So, and this is very well known, and we are aware of this. So all of these patients undergo surveillance with ultrasound scan before, during, and after treatment. But yes, and targeted therapies, immunotherapies, they all have specific toxicities. Laura mentioned doxorubicin as being a dumb therapy, so a drug that doesn't just breaks the DNA. Well, now oncologists have become like very sophisticated, and they are using very targeted molecules that target specific molecules. And we were expecting for this to not have so many side effects on the heart. But the thing is that they are targeting molecules that the heart cell needs to survive. So again, we will be expecting different types of toxicities. But the good news is that we are now aware of them, and hopefully what happened to Philippa, that nobody was even thinking about the heart as being the cause of her symptoms, should be the less frequent, should be the rare event. Yeah, we should.
Yeah, thank you very much. So I'll merge these next two questions, Priya, maybe for you. Are there ways for this person, they say, to reduce damage to my heart during chemo? And the second one is asking for specific dietary or exercise recommendations for cancer patients in that regard.
Yes, I think, again, what Sol said, so things, just ways to protect the heart, ways that we usually would through lifestyle and diet changes. Very often, if patients are referred to me, I try to refer them to cardiac rehabilitation. And through the British Heart Foundation, there are also home video exercises that they can do, which are really helpful. And I know you can find your own cardiac rehabilitation centre as well by putting a postcode in. So I recommend cardiac rehab and regular exercise. Resources like the British Heart Foundation, Pumping Marvellous, Maggie's is also very good for post-cancer care as well as MacMillan. All give very good advice on diet and exercise and ways to just protect your heart during your cancer treatment.
Okay, thank you. Philippa, a question for you. And how did you cope with the physical and emotional challenges of cancer treatment?
I don't know, really. I'm just that sort of personality that I just get on with it. I'm nothing special. And I don't know, as I said earlier, it's probably because I was a little bit naive. I can relate to other people that are going through it and think, yes, it's hard, etc., etc. But when you're in the middle of it and you're on your own, I live on my own. I've no family that live close by. So yeah, it was live or die, more or less. You just get on with it. You know, as simple as that. I'm sorry, I have no words of wisdom where that's concerned. Just keep looking ahead. I used to cross the chemos off thinking, I'm one step nearer, I've got to the end. Yeah. Sorry, I have nothing profound to say.
Don't apologize, Philippa. Sometimes it's not what you say, and it's the way that you say it, and it's the positive way that you say it. I think it will, people will take the message from as much as of what you said as well. You guys have been talking about future research, but are there any present treatments that can reduce the risk of heart disease in cancer patients?
Yeah, I mean, there are no specific treatment for, I mean, cancer therapy related cardiac dysfunction, but there are all the cardiac therapies that we have available, and there is evidence that this also work, not only to treat cancer therapy related cardiac dysfunction, but also to prevent. So if a patient is considered to be at high risk of developing, for example, heart failure with doxorubicin, and if we will probably follow them up very closely with a scan, with an ultrasound and with biomarkers. If any of these tests are abnormal, even before the patient has any symptoms, we have medical options, beta blockers, ACE inhibitors, or carvedilol, mainly you might have probably heard about it, or ramipril, there is evidence that they are cardioprotective. So this is in the cardioprotection scenario. In the treatment, then we start with these drugs when there is established heart failure. We start with these drugs, and then we escalate, and Priya can tell you all about it. She works all the time with helping titrating all the medications that are available for heart failure treatment.
Okay, Philip, if you've got your hand up.
Yeah, I'd just like to ask the other speakers, because I'm finding this really educational as well. Is this build up prior to chemotherapy, the ongoing monitoring of symptoms, etc.? Is this the norm, as it were, now, or is it just the ideal model? We all know that there are certain centres of excellence, shall we say, where these are in practice. But is this across all NHS trusts now? It's new to what I experienced. What I did find was everything seemed to be targeted for breast cancer patients, people that were having chemotherapy at the same time as myself. They'd had an echocardiogram prior to starting the treatment. They were continually monitored, but other cancers seemed to get sidelined. As well, on top of that, there seemed to be a reluctance as well for haematology, especially, to refer to MacMillan for some reason. I just wondered if this was the general thing or if it was just in an ideal world.
It is becoming the norm, and it's much more common nowadays than it was 10 years ago. Unfortunately, we were aware, but we were not there yet, I guess. We're still not in the ideal world where everywhere in the whole UK or anywhere else in the world, everybody who's going to receive potentially cardiotoxic chemotherapy receives a baseline assessment. But we are working very hard in educating oncologists and hematologists so that they can do the assessment themselves and then refer those who they think are at risk. And then there are some certain drugs that, yes, they are the norm because it's in the black label. It's in the label of the drugs, such as Herceptin. Herceptin cannot be given without echocardiographic monitoring. But yes, Philippa, obviously there is an ideal world. There is what happens in London, for example, and in other parts of the country. And but we're much better now than we were 10 or even 20 years ago. Yes, I don't know. Priya, maybe you could tell us a little bit about what your experience with the heart failure and cardio-oncology nursing experience.
Yeah, I think it's very difficult. It's again, as Sol presented, it's almost like a double whammy. So not only do you end up you have cancer, but then you also have a cardiovascular complication, and it's very difficult. I think communication is so important between the cardiology team and the oncology team, and we are very lucky being based in the centre of London, and we have the Marsden next door. But from a lot of patients, I find it's some of them just need somebody to speak to, and if they are experiencing those symptoms of feeling breathless and having chest pain or any of the red flag symptoms, I often will try to, if I don't think it's cardiac, I do then speak to the oncology team, and it's gotten a lot easier with the CNS role evolving, but it's difficult because it's true, not all centres are practicing the same way, so I think it's just creating more awareness.
Okay, I'm going to have to wrap it up here, guys. Thank you very much, everybody. Laura, Priya, Philippa, and Sol. Just a couple of words. People are saying they're in awe of you, Philippa, for your attitude, positivity, and approach. And thank you very much indeed. Thank you for watching this live edition of Live and Ticking. We hope you've enjoyed hearing from all of our brilliant speakers. Before we wrap up, I'd like to ask you the poll question again. This time, how would you rate your understanding of cancer and the heart now? 1 is for very little and 5 is for a lot. If we haven't managed to answer your questions here today, then we encourage you to visit our Heart Helpline, where you can contact our dedicated clinical team about your query. You can also contact the MacMillan Support Line, and you'll find the details on the screen below. This is all made possible by you from your generous contributions and support. If you'd like to make a donation towards our life-saving research, there's a link in the chat box to do so. We strive to produce the best events possible for you, our audience. Your feedback and comments are crucial to help plan and develop future events. So we ask if you can complete the survey at the end of this event or through an email you'll receive in the coming days. This live and ticking event was recorded and will be available on our YouTube channel from next week. Our monthly live and ticking webinars have been running since July 2020. To improve the series, we're working on some exciting changes to enhance your experience and bring you the latest in innovative BH-funded research. So the series will now take a break for the remainder of the year. However, our refreshed and rebooted series will return in January 2025 as a quarterly webinar. More details about our new quarterly series will be available soon on our website. In the meantime, all live and ticking webinars from the past 4 years are available to watch on our YouTube channel. Thanks again for joining us, and we'll see you in 2025. Goodbye.